video arcades. In the late 70s, 80s, and 90s, that was the place to go, and you could spend a few quarters to escape reality and see your imagination come to life on the screen. And as a kid, I always wanted to have my own arcade game in my house, just like on silver spoons, or perhaps being enticed by the back of a cereal box that said I could win my very own arcade game, and they would deliver it to my door.
Boy, you sure do like healthy cereal and this video arcade game I want. The real thing?
You too could win a
Super Hackathon!
These days, it's not difficult to emulate all those old games that we know and love, and I've built a few arcade cabinets of my own over the years. But I've never owned my own full-size arcade cabinet, one of the originals, or even really played around with repairing one of them. So you can imagine my excitement when I went to eWaste this week and found this. A PCB from a 1991 arcade game called Sunset Riders. I found it sitting next to the dumpster in a pile of PCBs that were about to be sent for scrap. Will it work? How do you even go about testing something like this? And of course, how much should I pay for it? It's coming up right now on the Retro Hack Shack. All right, well, you guys have no idea how excited I am today. I know there are other people that focus on repairing arcade machines, arcade cabinets, arcade games. But, you know, for me to find this just about ready to go in the dumpster and be able to save it and test it out and play with it today really is a dream come true for me. So I hope you enjoy going through this today. And maybe if you find one of these boards, maybe whatever I'm doing today will help you out in some way as well. Today is E-Waste Wednesday. Before I get ahead of myself, I must mention that. And of course, E-Waste Wednesday, you take those letters and you get ew.
Ew! Get off of me! Ugh, as if!
And if you've ever seen any of my other E-Waste Wednesday episodes, you know that ew is pretty good at describing some of the things that I find at E-Waste, but not today. This is actually in really good shape. I literally saw this on top of a pile of PCBs, and the thing that caught my eye right away on this was this chip right here. And if you know anything about computers of the late 80s, early 90s, many of them were powered by the venerable Motorola 68000. And I saw this from a mile away and I thought, ooh, let me take a look at whatever that is sitting on that pile of PCBs. And sure enough, I was not disappointed when I looked closer. So let's take a quick look at this board from what I've been able to decipher and find over the past little bit here looking at it. In a lot of ways, these early-ish PCB boards that were in the arcade games that we all loved and played were really just single-purpose computers. They had a CPU, they had memory, they had maybe some storage of some sort, they had sound capabilities and video capabilities. So I'm hoping today, by going through this, you know, it'll be fairly similar to whenever I work on an old computer like I do on the channel. It should be the same sort of process that I go through. It's just physically a little bit different. Now here's the CPU, as I mentioned. It is a 68000, Motorola 68000. And yep, same chip that was in the Macintosh, same chip that was in the Amiga, same chip that was in the Atari ST, so on and so on. Used in so many machines, very powerful. And also right away, you can see there are some EEPROMs. That's why we have like 4 EEPROMs here and then another one over here, which is kind of interesting. Shortly after filming this, I discovered that there's actually a second CPU on this board, and it's right here. This is a Z80. So we really have 2 of the trifecta CPUs here, the 68000 and the Z80, which is used for processing the sound. And that's probably what's on this smaller EEPROM right next to it as well. This will most likely contain the software needed to run the game. So the actual game program will most likely be on these EEPROMs, and that's the storage that you would typically have in a computer. The other thing that's on here that I noticed is memory. Now, it took me a little bit to find it, but it's these chips here. There's 1, 2, 3, 4 of them, and then maybe a couple more over here. My eyes aren't working very well right now because I've been soldering all day, so my eyes are a little bit crossed here. But these are static memory, so not dynamic memory or DRAM. These are actually static memory chips. There are a lot of custom ICs on this board. This is a Konami game, and so you'll see Konami chips everywhere, all around the board. There's Konami, 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 Konami. So a lot of the logic and things like that has been integrated into these packages, and that saves a lot of space and probably allows them to get a game like this out on a single board. But there are a lot of logic chips still on the board. Over here, I know a lot of these are used as part of the video processing from looking at the schematic for this thing. Yeah, there's still some discrete logic chips sprinkled all over the board. One thing that's interesting that I did notice is that normally with ICs like this, you'll have some capacitors, decoupling capacitors, sitting next to the chips. Like in a Commodore 64, for example, you'll see those little disc capacitors, and they'll be all over next to every chip. And this board doesn't have them. So maybe at this point, the quality of the ICs were good enough that they didn't feel like they needed them. If you know more about why that happened, I mean, there's not even any like surface mount ICs that I would have expected, or surface mount capacitors that I would have expected. So if you know more about, what happened here is in terms of capacitor history and why there isn't more capacitors next to these chips, I'd love to know, and maybe leave some of that down in the comments below, and I'll pick that up and read it as this video comes out. So that takes care of most of the major components that you would typically see in a computer: CPU, memory, storage, video, which I mentioned is going through these logic chips here. What about sound? Well, the sound chip is right here, and it's a YM2151 made by Yamaha. And this particular chip was used in a lot of arcade games. In fact, the first time it was used was in Marble Madness in 1984, and used in a ton of games from Konami and Capcom, Data East and Namco. So pinball machines. It was really widely used in a lot of different boards like this. It was used in synthesizers. It was used in some keyboards as well. I think so. DX keyboards, Yamaha DX series keyboards used it as well. So yeah, really widely used sound chip, and that's what's powering the sound here. So now we have all the components, traditional components that you would typically see in a computer. They're all right here on this motherboard for this game. So now you might be thinking, okay, well, where do I hook up the monitor? Where do I hook up my mouse and my keyboard and so forth? Well, of course, there's no mouse and keyboard here. You're going to be interfacing with this game via buttons and joysticks. But I wanted to mention that the way you interface with this is through this JAMMA port over here. This is a standard port that was widely used back in the 80s, late 80s and early 90s. It came out of the Japanese Amusement Machine and Marketing Association. Apparently, they came up with this standard, and it was referred to as JAMMA. And then this carries the video connectors. It is also the interface for power and all of the joysticks and buttons and things like that that you'll use. The coin op button that, when you insert a coin, like that is controlled through here. There's a signal that's passed on one of these pins for that. Player one start, if that's a thing for your particular game, that would all go through the JAMMA interface here. If you had one of these arcade machines and you wanted to upgrade it to the latest game, change it out for a different game, for example, it would be fairly easy for you to pull the PCB out of one game and then pop in the newest game from Konami or whoever, and then hook up the wiring harness, maybe make a few small adjustments for buttons and things like that, and then you'd be up and running, and you wouldn't have to throw away the whole cabinet or buy a brand new cabinet. You could actually just upgrade the artwork on that cabinet. Because if you think of it, a lot of the cost of these games was down to the cabinet itself and the shipping of that cabinet, because they were quite heavy. Now, there's a couple other ports on here that are important. So there's a sound port over here for left and right speakers. And then this particular game is one of the few of this era that actually allows you to play 4-player. So there are some additional ports here for player 3 and player 4 joystick and buttons. So yeah, you could actually play up to 4 players on this game. And another reason why I'm so excited to have it, because this, I think the Simpsons, maybe Teenage Mutant Ninja Turtles, which I think this might be a clone of, with different ROMs. had 4 players. Gauntlet, I think, had 4 players. So what you need to interface with this, so the easiest way to interface with it is with a JAMMA harness, which this is. I got this on eBay, and it has a connector, which will plug into this connector here. And then all of the power and video and controller joysticks and buttons and everything is all broken out. And it's labeled with a standard here, although, like I said, this would vary from game to game depending on what the controls were. And so even though that button might still be on that port, it might go to jump, or it might go to shoot, and that may switch on a different game. So there might be some small adjustments that people had to do to get things wired back up differently if they swapped out one of these PCBs. But this is what I'm going to be using to interface with this board today, and hopefully by the end of this video, we'll be playing some Sunset Riders. So the first thing I want to do before I do anything else is a little visual inspection, but I've got to say this board is in great shape. And I just have to tell you, I really had to resist the urge to test this out and hook it up ahead of time. I try not to do that. Most of the time what I do is I record the video along with you so you can see it all in real time. I don't pre-do anything, or I try not to do that as much as possible. And I really had to restrain myself because I was so excited to get into this. But yeah, I'm just looking at the capacitors, especially no leaking that I can see anyway. No bulging capacitors, no popped or burnt resistors anywhere. Like I said, there's very little capacitance on this board, which is kind of shocking. Now, some of these packages here are going to have discrete components inside, and those will be covered up with this material. I don't know if it's like a shrink material or whatever that they put over there, and then they just solder these in. So all these dark packages here have discrete components, and you can feel them. But these were probably, needed for several boards. They were mass produced, and then they used this material so that, they didn't short anything out after they were placed in the board. So there's several of those along the board, but so far I can't see really anything. There's a few bent pins there that I'll have to straighten if I ever want to use those, make sure that they're not shorting anything out there. But yeah, everything so far is looking really good on this board. Next thing I want to do real quick is test for shorts, just to make sure that the various voltage rails are not shorted out to ground or to each other or anything really. So I've got my multimeter here, and I did reference the pinout from the technical manual, which is really good, by the way. The technical manual was able to find it, and it's got the pinout, of course, for the JAMMA board, what's used and what's not. And then it also has some really good high-level schematics, I should say. So some of these custom chips, of course, they don't go into a ton of detail on what they do, but you can kind of figure it out from the schematic. Even though you can't figure out exactly how the chips work, you can at least see what they're supposed to be connected to. So this should be ground over here. And let me just double check and make sure that the middle pins here on the soundboard, I need to know that anyway. Those are both ground, the middle ones, and then the outer ones would be the where the signal's coming for the sound. So that's good to verify that. And then here we've got, I think this is the 5-volt rail, and that is not shorted. And then the 12-volt rail. And that little beeping you hear is just a capacitor that's going across the rails. And as that charges up, it makes the multimeter makes the multimeter beep at first when it's charging, but it is not indicating a short. So yeah, no shorts on the power rails. Time to move on to step 2, or whatever step we're on. All right, now let's talk about the rest of the components I'm going to be using to test out this board. Well, we need a power supply, so for that I've got a PC power supply. I think this is an AT or early ATX power supply, and the only thing that I think I need to look out for here is the voltage rails to make sure they have enough amperage. Now, I looked at the specs for this particular board. They say that it does need 4 amps on the 5-volt rail, and then the 12-volt rail was, I don't know, something less than that. And so a good way to tell is just to, hopefully your power supply has a reference for the various voltages and amperages that they can supply. This particular power supply on the plus 5 volt rail supplies up to 80 amps max. That's awesome. And 12 volts is 18 amps. So it should have no problem powering this board. Of course, if I was going to rebuild this in the actual cabinet itself, then the power supply would most likely be powering some other things as well, like the monitor, for example. So you have to take all that into account, but we don't have to worry about that here, just whatever the board is going to draw. And then to interface with this, we need a joystick and some buttons at least to be able to play the game and test it out. And for that, I'm going to be using one of these, I don't know what they even are, arcade emulator things that were popular back in the 90s, early 2000s. You could find these all over the place. I happen to find this one at Goodwill for $4.99, but you can find them all over the place. They're all over thrift stores and eBay and, you name it. You can find these things in various shapes, forms, playing different games. And they typically have a composite output. Composite and not even stereo, right? It'll just be mono output. So what I'm going to do is take this apart and wire up the buttons and the joystick to the board. But that's easy enough to do. This one is a toggle switch, so that doesn't work. Oh, look. There are batteries in here. I guess the batteries still work for this thing. That's pretty funny. Now, to make the connection between the board and the TV here, I'm going to be using this. Of course, I'm going to be using this. This is the RGB to HDMI. I sell it on my website. I support the project. I think it's awesome. It can connect to so many old computers and give you pixel perfect quality HDMI output. I've shown how to do it on the Commodore 64, on PCs, on all kinds of things. I love using this device, and I'm going to use it again today because this board outputs analog RGB. And so with my little analog adapter for the RGB to HDMI device, I should be able to tap into those analog RGB signals and then pump that out through HDMI to this monitor. And so it should look really, really good. Even though this isn't a high quality monitor, getting it to this monitor in HDMI will make a world of difference in how this looks. So that'll be interesting to see if I can make that work as well. So the first thing I need to do is cut into this wiring harness. And this could get a little messy. Carefully cut that off, and you can see just how long the wires are for this. And on the end of them, they have standard, at least for arcade cabinets, primarily standard connections. Like, for example, I think this is the video connector, so that would plug somewhere in the cabinet to go to maybe another board that goes to the TV. And for the power, they have probably some spade connectors. And then for all the other connectors that go to the joysticks and buttons, they're going to also have these female spade connectors. And they have some nice plastic slip cover things to make sure that things don't get shorted out inside the cabinet. But these are going to be really, really long so that, in a real cabinet, you could snake these up through to the buttons and joysticks and everything. So a lot of extra wire here that I'll have to be careful doesn't get all tangled up into knots as I go about the process of hooking this up. Also, it's going to be hard to see, but on the JAMMA harness itself, there is a label here that says part side, and then there's a label on the other side that says, here it is, solder side. So that kind of tells you how to position this harness and plug it into the board. This board itself does have a gap somewhere in here that would be for a key so that you couldn't plug this in backwards. But this particular harness does not have a key in it. So it would be possible to plug this in backwards, and you don't want to do that. So pay attention if you ever get the chance to do this yourself. Make sure you pay attention and put the JAMMA harness in the right side up. Top side being part side, and then there's really nothing on the bottom except for solder joints, so that is the solder side. Okay, so what looks like a rat's nest here actually isn't, thanks to the manufacturer of this particular wiring harness, which I can link to on I think I got it on Amazon. I'll link to it down below if you want to pick one of these up. Really inexpensive for how much wiring is in this thing, but it doesn't look as bad as it is because the person that put this together, or a company that put this together, has connected all the wires such that they're in bundles. And so I've got a bundle up here for power and video. I've got 2 bundles for player 1 and player 2 controls. I've got another bundle here which is for service buttons and coin op buttons or coin op connections for so that you can detect when a coin is inserted, etc. And then I've got one last bundle that's really long that is meant for speakers, to hook up to speakers that probably would have been mounted at the top of a cabinet. So yeah, really well laid out, and this is going to make my life a lot easier because now I can just take what I don't need and wrap that up and bundle it up so that it doesn't get in the way. And then what I do need is easy to find because of the way that they put this wiring harness together. Okay, well, I have been diligently at work here, mostly doing cabling so that I can get ready to test this thing out. Let me just catch you up on what I've done in case you're following along with interest. So the first thing is I've taken this little Pac-Man arcade thing, whatever it is, apart and removed the AV cord here, and I'm not throwing this away. This will be really good to use for Commodore 64, for example. If you're running a composite mod, this is really good. You attach this end to your DIN connector, and then you've got audio and video on a nice long cable like this, and I've done this a couple of times. So this is going to go in storage. And then this is the Pac-Man arcade thing. This is where the cable, the AV cable, went out of. And then that went in and attached itself here. So I just desoldered that. And here you can see the inner workings of what's inside one of these things. It really is just a small PCB with a blobbed chip or two and some memory. And yeah, as cheap as they can make it, they will make it. But what I was looking for in here was the connections for the controls, the buttons and the joystick. So the buttons are down here, and they just kind of work their way around here with a cable and attach over here. And then the joystick just controls these little mini micro switches. Yeah, they're micro switches, but they're really small. So whatever you call those, I'm going to call them mini micro switches. And then what I've done is each of those micro switches is going to be connected to ground and another pin, and the ground is going to be common between these buttons. And I checked it with my multimeter just to be sure, and it is. It's common between the buttons and the micro switches. And the reason that's important is because we need ground and a signal pin to trigger the input on the board, right? So you press a button, it connects to ground, and that tells the board that you press the button. So that, because there's a common ground, that means I only need one wire running out of this thing for ground, and all these other wires are for the signals, the buttons and the switches, the micro switches, one wire each for those. Those will all come out of this where the AV plug used to go. And then what I've done is I've attached on each of those these little spade connectors. And what that does for me is that means I don't have to cut the JAMMA wiring harness. These will just slide into the actual spade connectors. So that way it's a nice temporary solution so that I can test this thing out. The other bit of wiring I've done is back here for the RGB connector. And I was trying to find something that would fit in the holes here, or in the sockets, the female part of the connector here, to run over to the RGB to HDMI. And what I found was that the pins from one of these old school sockets that you might see on an old motherboard, maybe either for power or for some other connection, they're kind of thicker square pins. What I found is that those are the exact size that I need for to fit in this connector here. They actually slide in there nice and snug. So what I did was I just took my soldering iron and heated up these pins and pulled them out of the plastic here, and then soldered on the wires in the appropriate positions for the RGB to HDMI board. And so now I think we're pretty close to being ready to test this thing out. All right, the last little bit I need to do is to try to figure out how to get sound connected here. And this is the sound output, as I think I mentioned before. And I was looking for something that would plug into this. And just like I save this stuff, I save all kinds of stuff that comes through the shack. One of the things I save is these little connectors. This is for a fan. This came from some fan that I bought or that I removed. And I thought, you know what, I'll just keep that connector there. And I don't know if this is 3 or 4 wires. It is 4 wires. Lovely. And I think it's going to fit right on that connector. Whoops. Yep, there it goes. Perfect fit. Yay. So, armed with, actually, why not use this? I've got this RCA jacks here that I was going to save for a Commodore 64. I can still do that, but I can connect the wires from this up to the wires from this, and that will give me 2 channels of audio, left and right. Perfect. And last but not least, I wired up this other button here, and this is for the coin. So if I do have to insert a coin, I can just press this momentary switch and it will insert as many coins as I want. Okay, I think we've reached that magical hour. The pucker factor is here, which means we're going to turn this on and see if it works. Now, I did hear back, I contacted Ian, the maintainer of the RGB to HDMI project, and I sent him a copy of the schematics for this board, asking him if he thought this would work with the RGB to HDMI, and he said no, because there's I think he said 15 or 16 bits of color coming out of the system, and this is only a 12-bit board. So this isn't going to work. I know that going in, but I still want to turn it on and just see if we get anything on the screen, and maybe even just hear some audio, just so that I know things are working or not. I think, fingers crossed, everything's ready. Power's plugged in. Yeah, I think we should be ready to go. I'm going to keep my finger on the power switch just in case. 3, 2, 1. Power's on. Oh, I heard something come across the speakers. Does that mean the board is working? There's no video signal. $68,000 is... Oh, look, RAM-ROM check. Ha! Woohoo! Winners don't use drugs, baby. Oh, awesome. This thing is totally working. Now, I told you the colors were going to be off, but look at this. Look at this. Oh, awesome. I cannot believe this thing is working. First time, baby. Okay, so clearly this is working. I might be able to get into the menus here. So let me just hit the test button. Yeah, so at least I can see the menus and I can walk through these. So let me zoom in so you can see the screen, and we'll come back to the video issues in just a minute. Okay, so now I should be able to test the controller out and see if that works. It does, it does! At least up and down work. Awesome. But, you know, it really does help, I will say, to have done a few of these projects before with arcades, kind of knowing what you're doing or watching a video like this, just to get your bearings. Man, it makes all the difference in the world. So one thing I want to do is I want to go down, we can do these checks, but the first thing I want to do is go down to coin options and set free play to yes. Free play, baby. Save and exit. So it's saving those settings, so it must be saving those to static RAM, right? Otherwise, there's no place else to save it. Let's go ahead and do I don't want to do the I/O check because that might go through 2-player or 3 players worth of controllers. So I don't want to do that, but let's do the screen check and see what that does. Okay, kind of gives you a pattern so you can line this up on your CRT. Color check. Colors actually aren't bad. I mean, we're missing some stuff here, but I've got red, yellow, green, cyan, kind of a dark blue, a pink, and a white. So that's looking good. Let's do a sound check. What does that do? Oh, this is... Whoa! That's pretty cool. Okay, let's do the mask ROM check. All the mask ROMs are okay, baby. This is awesome. There's also some game options here. You know, when I was a kid, I will tell you that the thing that I wanted to do the most when I saw the people that were running the arcades come out and they would open up the drawer and sometimes you could see them fiddling with these settings. You knew there were settings in there that you could do like free play and stuff. Even as a kid, you know, 10, 11 years old, you knew there were some of these settings that you could mess with and you couldn't get in there because they had the key and they would lock it up. Well, this is what I'm able to do right now, baby, with my brand new arcade board. I can mess with this to my heart's content. Oh, there we go. Oh, game mode. I thought that was a special game mode, but that's going back to game mode. So here we have press start for any of these players. Nice. Yeah, it's working. Look at that. Doesn't look very good. Oh, and I can go diagonal if it is working somehow to go diagonal. Maybe I can press up and over. Yeah. So the diagonal isn't working, but I can press up and over to make it go over. So that's cool. Okay, so on to fixing the video. So there are at least 4 ways that I can think of off the top of my head to deal with the video issue so that we can get good quality resolution to really see what this game looks like. The first, and I think most obvious one to most people when they do any kind of searching for arcade, JAMMA board, video output to HDMI or video output conversion, any of those kind of Google searches, you'll come up with these boards that have been made, that come out of China mostly. There's 2 types. There's a green one and then there's a blue one. The green one, I believe, outputs to maybe VGA or DVI, I think, depending on which one you get. And then the blue one actually is an updated version that outputs to HDMI. I don't have one of these boards, but I have ordered one. And if one comes in before I finish recording this, I will put it in the episode and show you how it works. But essentially, those are really nice, especially when you're upgrading a cabinet to modern technology, a modern display or something like that. You can mount that right inside the cabinet. The one that I ordered also has this exact connector for this that mates with this one that's coming off the JAMMA harness. So you can just plug that right in and get HDMI out. The things that I've heard about them, though, is that the accuracy on them isn't great. Sometimes the output doesn't look quite right. And there's even been some updated firmware for some of these to improve some of those things. So the quality may not be great, but they're inexpensive, easy to get a hold of. You can buy them anywhere. That's one option. Another fantastic option would be the OSSC, the open source scan converter that so many people use. And I do not have an OSSC. I have ordered one of those just because of this project. It's forced me down to the fact that I do need to get a hold of one of those at this point. I just don't do a lot with RGB and VGA. Mostly I'm working on older technology that I can use the RGB to HDMI device with, but that is a great option as well. It supports tons of formats and does a great job with converting and great community around it. So if you have one of those, obviously that would be probably your go-to for testing. I happen to have a couple other devices that I could use. One would be this device. It's an Extron RGB-HDMI 300A. And this particular device does a really good job with all kinds of VGA and RGB inputs. And it's got on the back, sorry, that's upside down. Can't be bothered to turn it around. It's got the VGA input that also accepts RGB that you can attach. I'll show you how I'm going to do that in a minute. But simple little device. It also takes audio in and then it combines that into HDMI output. So this device I've used in the past and it's pretty good. So I want to take a look at this and just see what the quality is like running through this box. Last but not least, in terms of options, is this device. It's the Startech USB3 video capture device. I use this for almost all of my video capture that I do for the channel because it has USB input, it has DVI, which also could be VGA with an adapter input, and it has composite, it has component and S-video. So I use this all the time. It's my go-to jack of all trades capture device. Pretty good quality, better than a lot of other stuff that I've seen floating around. And I don't think they make this anymore, so it might be hard to come by, but this is another great option. Anyway, this supposedly with some drivers that have been produced by the community, this is also able to input or take as an input RGB input like 240p, 15 kilohertz, so the kind of stuff that we're talking about with this board. And of course, this is a capture device. So if I wanted to capture this, this would be what I would try to use, or I would just use an HDMI capture device after going through one of the other options I mentioned before. Let's do a quick test on this Extron box and see if that works. And to make my life easier, I bought one of these cable breakout cables, the VGA breakout cable, and these colors here correspond to the numbers on the pinout, the VGA pinout, so that I can easily tell which signal I need to hook up where. So yeah, I'll be using this to make my life a little bit easier, not only for this project, but in the future as well. All right, well, I'm all set up with the Extron. I've got my, I think, the right signals going into this thing, so we'll see. I may have to do some adjustments here, but it is on, so let's go ahead and turn the power on to the arcade board and see what happens. Okay, well, I'm definitely getting something here, but as you can see, this is definitely also not correct. Okay, well now you can actually see that we are getting somewhere. So we do have good video coming out. The Extron box did not work. So I think I got some bad information online. There were some reports that it would work with a separate horizontal and vertical sync signal. But this only puts out a composite sync signal. So I moved on to testing the Startech capture card, and that is working just fine. So you can see the output here on the TV. Certainly this would be playable, but actually what you're seeing is the output of OBS capture. And by the way, I'm capturing this, so I'll overlay some of this so you can see what the direct capture looks like from this device. But yeah, it is working, and there's OBS there working behind it on my desktop, on my laptop here. And I just had that projected to full screen so that we could see it on the TV here. So yeah, it's projecting that at 1080p. And let's see, projector, woo, hard to do this from an angle. There we go. So there, we're back to projecting OBS onto my mirrored display here, which is on the TV. So yeah, the Startech actually does work for at least the signal that this particular board is producing. One thing to note is that it stretches it out about twice as far as it should be. So I had to take this and shrink it horizontally back down to half its size in order to make it look correct. But otherwise, it was certainly workable through OBS, no problems. And as you can see, it's looking great. So I could actually play this now. Oh, I didn't know I could go. Oh, look at that. Oh, hello. Oh, she gave me like double bullets or something. Cool. This is a fun game. Oops, was I not supposed to do that? Was I not supposed to? Oh, she gave me something. Whoa. Yeah, so obviously I have never played this particular video game, and what? The horses are laughing at me. Why are they doing that? Oh, that's why. Run to avoid getting killed. Okay, this is super fun. The video is looking great. So yeah, at least this method for getting video off of this particular board is working great. All right, well, look what just arrived in the mail just in time to test out as part of this video. This is the board I was referring to, which is perfectly designed to fit in a cabinet and custom made for RGB conversion like this. It's got HDMI out. It's got a pin header down here, which matches the pin header on the JAMMA harness. Looks like it has adjustments for red, green, and blue, which is awesome. And it also has some buttons over here. So there must be a menu of some kind. It'll be interesting to see if we make changes to the menu and reboot this, whether it will keep those settings or not. I'm assuming that this is the memory here, so I hope it does. But yeah, this should work really, really well. This is the HDVC 9900-VL1. And like I said, you can get this for about $35 on Amazon. Amazon sent it to me using Prime with free, essentially 1-day shipping. It took a day and a half or so to get here. So really glad they had this in stock, and at least I can show it on the video. So let's give it a try. All right, HDMI is connected, and I'm plugging in 5-volt DC to the barrel jack here. And I don't have the board on yet. I don't have the arcade board on yet, so let's just see if... Oh, yeah. Oh, hello. No signal. Okay, so yeah, it came up with some Chinese characters, and unfortunately my Mandarin is not good enough to read them, but came up with no signal. And it does look like this is, you know, the TV is going to be under scanning, I guess. Or there's going to be some overscan here to deal with, and this TV doesn't have a way to do that in the menu, at least not easily, without entering some sort of code or something. So hopefully the board has a way to deal with overscan as well. But let's go ahead and turn on the board and see what this looks like just right out of the box with no changes or anything. Okay, oh, that's good. Okay, yeah, here we go. Nice. Winners don't use drugs. Yeah, we're in like Flynn. And yeah, there's overscan happening here that we'll have to try to fix, but so far the colors look good. The resolution isn't quite as good. It is a little bit fuzzier, I would say, the pixels. And it looks like it's a little bit off on the geometry as well. So let's go into the menu and see if we can fix this. I'm just going to follow along here. Okay, here's the... Oh, hello. More Mandarin. Let's see. There we go. English. So number 4 is... lets you set the language. So we've got English and we've got Zhongwen, I think, if I remember correctly. Now we're in English, so we can do things like geometry and display. Let's just take a look. We've got brightness, contrast, saturation, sharpness. Okay, cool. Position, size, clamp. Okay. So yeah, let's change the horizontal position. Oh, and we can adjust the display size, it looks like, too. So this is set for 800 by 600. I could go to 1024 by 768. Now you'll notice, though, that maybe it's the TV or whatever, it is stretching this out. So it's stretching it out to widescreen. Whoops. Let's see what this looks like if we change the resolution. Okay, that's looking a little better, but now the geometry's off again. Let's bring it up as far as it can go. Okay, yeah. So that looks a lot better, but now, once again, the geometry's off. So let me go fix that. Okay, well, that looks pretty good to me. Everything is on the screen that needs to be, and if we start the game, it all looks good. The colors look good to me, but I don't know what the color reference is for this game, so, you know, who knows. But at least nothing is off the screen at this point, and whoops. Oh, there she goes again. Thank you for the kiss. And get that bag of money. So now let's go ahead and reboot this little board here and see if things go wonky, because that would defeat the purpose if I had to reset this every time you power up the board. So let's just see. Okay, the board is off. I'm going to let it sit for a few seconds. Plug it back in. I gotta imagine these settings are saved in RAM here, but should come back on. And yep, everything is where it's supposed to be. So good. So it does save those to memory. So everything looks good here. So this is a quick, easy board that you can implement either for testing or to actually install this in a cabinet and replace the CRT if you wanted to with a flat screen display. So everything's looking good here. I could not be happier with this setup. So at this point, you're probably wondering what this cost me at eWaste. And that's where that gets really exciting, because I actually was able to pick up this board. I also picked up this SATA IDE to USB board. You can't have enough of these. I think I have one for all 3 different types of USB. And then also I picked up this ATI Radeon X850 Pro. So I picked up all of these kind of as a bundle, and I paid only $5 for them at eWaste. So that means that this arcade board actually only cost me $1.67 when you split it up evenly. So I was really happy to see this. I'm super excited that it's working. And I did a little research online. It turns out that these boards go for quite a bit of money in the aftermarket. The last two that I've seen that have sold on eBay went for about $500 a piece. I don't think I'll be asking that much for this board if I decide to sell it, but it is working. It's in great condition, and yeah, the proof is in the pudding. So I'm super excited to have this working. I know I'm going to go play some more of this game right now and enjoy it before I have to clean up my table here for the next episode. If you enjoyed this episode, be sure to hit the like button. It does tell YouTube that people like us geeks, really like this kind of content, and then they'll share it around with all of our friends automatically. At least that's how it's supposed to work. So I do appreciate that. Thanks to all my patrons. Thanks for watching, and we'll see you next time. Patrons receive ad-free and early access to content after the episode commentary, and of course, your name in the credits. If you liked that episode, here's a few more you might enjoy, and I thank you for your support.
End of line.